If you ever find yourself contemplating whether to invest in a product marketed as a detox, my advice is simple: don't. Your body possesses the natural mechanisms necessary for detoxification, namely the liver and kidneys. In fact, having two kidneys is preferable, although the inner workings of these bean-shaped organs remain somewhat mysterious. They function as cleaning stations for your bloodstream, where dirty blood enters and exits as clean blood and urine. But how does this intricate process occur? In today's presentation, we'll delve into the intricacies of kidney anatomy and the physiological processes involved in blood purification. Greetings, and welcome. For those new to this channel, I'm Patrick, and here we explore the wonders of human anatomy and physiology. The kidneys play several crucial roles in maintaining bodily equilibrium, including regulating fluid levels, balancing ion concentrations, and eliminating waste from the bloodstream through urine. Each kidney, roughly the size of a closed fist, resides on either side of the spinal column, just above the lumbar region. Typically visualized from the rear, these organs lie behind the abdominal cavity, alongside other major organs. Additionally, each kidney is accompanied by an adrenal gland, situated atop, responsible for secreting adrenaline, a fitting nomenclature, considering the Latin root renal pertains to the kidneys. Descending from the kidneys are two ureters, conduits that ferry urine produced by the kidneys to the bladder, whence a urethral passage expels it from the body. Notably, the urethra is shorter in individuals with vaginas, predisposing them to urinary tract infections. However, upon dissecting the kidney, we uncover fascinating structures. A common sight in educational settings, the kidney's cross-section reveals three distinct regions: the cortex, medulla, and renal pelvis. These components, though complex, can be simplified for easier recall. The cortex, akin to the brain's outer layer, envelopes the kidney like the letter C in an O. Meanwhile, the medulla, nestled within, shares linguistic similarities with medium and middle, denoting its central position. Finally, the renal pelvis, despite its dissimilarity to a skeletal pelvis, serves as a conduit to the latter, often depicted in diagrams as yellow, signifying its role in urine transportation. Within this intricate network of blood vessels and tubules lies the renal pedicle or hilum, wherein the renal artery delivers blood, the renal vein carries it away, and the renal pelvis dispatches waste to the bladder. These primary layers set the stage for blood filtration within the kidneys. Though the cortex appears thin, it houses numerous nephrons, the kidney's functional units responsible for blood filtration. Multiply these nephrons, numbering in the millions per kidney, and a fully operational organ emerges. Given that filtration primarily occurs in the cortex, pathways for blood ingress and egress, as well as waste disposal, are essential. Enter the medulla, a conduit for blood vessels, known as renal columns, facilitating blood transportation to and from cortical filtration units. Moreover, renal pyramids within the medulla direct waste products to the renal pelvis via a series of ducts. Typically, each kidney boasts around 8 of these renal pyramid cortex combinations. Visualizing each lobe as a pizza slice, with urine-colored cheese and blood-red crust, provides a memorable analogy. Collectively, these anatomical features elucidate the kidney's blood filtration process. A significant volume of blood, approximately 20% of cardiac output, enters via the renal arteries, branching into arterioles upon reaching nephrons. These arterioles coalesce into glomeruli, clusters of specialized capillaries, reminiscent of entwined vessels, filtering blood through minuscule fenestrations. Each glomerulus, housing thousands of fenestrations, permits passage of small particles while retaining larger constituents. Encased by epithelial cells within Bowman's capsule, this unit forms a renal corpuscle, initiating filtration. Subsequent tubules navigate a labyrinthine route across the kidney, engaging in tubular reabsorption and secretion. Proximal convoluted tubules reabsorb vital substances, such as water, glucose, and ions, back into circulation. Conversely, the loop of Henle selectively retains ions while permitting water reabsorption, driven by osmotic gradients. Distal convoluted tubules further regulate ion concentrations through active transport mechanisms. Finally, collecting ducts channel filtrate towards the renal pelvis for excretion, culminating in urine production. Tubular secretion supplements filtration by expelling undesirable molecules, such as drugs and metabolic byproducts, into tubules for elimination. Additionally, this process aids in maintaining blood pH within a narrow range. Despite some urea reabsorption, sufficient quantities remain in urine, alongside other waste products. Upon completion of these intricate processes, urine traverses renal pathways before eventual expulsion from the body. In summary, kidneys execute a vital role in blood purification, generating copious filtrate while conserving essential nutrients and regulating bodily fluids. This overview scratches the surface of renal physiology, leaving room for deeper exploration in future discussions. Thank you for joining me today. If you found this presentation enlightening, feel free to suggest topics for future videos in the comments below. Remember to engage with fellow viewers' suggestions by upvoting your favorites. Until next time, stay curious and stay healthy. Thank you for your attention.